All right, so today we are combining what we did yesterday, which was graphing simple rational functions, what we did yesterday, with the day before, which was long division. So today is January 9th, 2020, graphing general rational functions. All right, so this is a simple rational function, and I know that it's simple because it's just this very simple number, -2, on the top. It's just a value. Compared to what we're going to see today, which is this, where we have an x on top and bottom. The simple one only has the x on the bottom. And what that means is it's a fraction that's already been reduced, okay? And so we want to identify from yesterday the vertical and horizontal asymptote. What's the vertical asymptote? X equals -4. Please remember, you need to write the x equals and the y equals. On your test for this material, there's a section where I say, what's the horizontal asymptote? Or what's the vertical asymptote? And one of your choices is going to be x equals -4, and another choice is going to be y equals -4. You have to know which one it is, okay? Two are going to look right, and you need to know. So get in the habit of writing x equals for the vertical asymptote. What is the horizontal asymptote? Just -1 or y equals -1? Very good. So once I know that, I can do a little sketch. 1, 2, 3, 4, 5. And so I'm going to do some asymptotes. Asymptotes are boundary lines. So this is x equals -4. We go to -4 on the x-axis and draw that vertical line in. We go to -1 on the y-axis, and it's a horizontal asymptote, so a horizontal line. And once we have that, then we can do a little XY chart to figure out some ordered pairs. And you can totally use a calculator for this if you want to. But what are some good values for x? -5 and -3. -5 and -3, we choose those because to the left and to the right of that vertical asymptote are going to be nice, easy points most of the time. I'm going to take this -5 and plug it into my equation so that I can get the y value. Now, ladies and gentlemen, if you have your calculators and you want to, you can plug it directly in, just making sure you put parentheses around the denominator. So watch. I'm going to take -5 and plug it in place of x. So in my calculator, I'm going to do -2 over parentheses. In place of the x, I'm using -5. -5 plus 4, and then subtracting 1. I can plug that whole thing in and get -1. I can also do it by hand, which doesn't take a lot more time. Again, if I take my -3 and plug it in place of the x, so I have -2 divided by the quantity, -3 plus 4 minus 1, we get -3. You can do it by hand very easily as well. Here we have -5, 1. I'm going to plot that point. And rational functions have the hyperbola shape. You see we have this boundary fence here, and we want a shape that's very close to that fence line, just rounded, nice and smooth. Guys, this is math class. You shouldn't be having that much fun. Right. And then again down here, -3. And again, that's just that hyperbola shape that's rounding the fence line. Okay. Tomorrow, the functions get more complicated. And if you have a graphing calculator, you're going to want to bring it. If you do not have a graphing calculator, I suggest you go to the finance office. I just put down 22 more calculators. Get one. Go check out a calculator. and we're going to use it tomorrow. In fact, you use it for all of these, which is a big help on your test. And you should know that on the test for this, most of it's matching. 15 questions are just matching. You've got functions on one side and graphs on the other. This one goes with B. This one goes with C. I don't know, but you're just matching. A graphing calculator would be very helpful. So try it with your graphing calculators. Here we go. Today we're going to use long division because this is not a simplified rational function. It's not simple. Why do I know it's not simple? How do I know it's not simplified? What's the difference with this one? There's an x on top. The other graphs we did yesterday didn't have the x on top, okay? So because it's got x's on top and bottom, it can be reduced. It's like reducing a fraction, an improper fraction. We want to convert it to a mixed number. And so we're going to write, using long division, write it quotient plus remainder over divisor. So Q is for quotient plus remainder over D for divisor. All right. So, and once we do that, then we can do everything we did yesterday, the vertical asymptote, horizontal asymptote, and then graph it. The divisor is x minus 3. So I'm going to do a little division here with x minus 3 into 2x minus 2. What's the algorithm for long division? Divide, multiply, subtract, bring down. What are we dividing first? 2x by x. Yeah, 2x divided by x gives me what? Just 2. And that goes on top. That's really, really nice. All of your long division today is one step. Well, one procedure. That's it. You don't have to do much more. We're going to multiply. We're going to take this 2 and multiply it to the divisor. 2 times x is 2x. 2 times negative 3, negative 6. And then we need to subtract everything. 2x minus 2x is 0. What's negative 2 minus a negative 6? 4. Negative 2 minus a negative 6. What happens to the minus the negative? Addition, yeah. So that's 2 negatives and 6 positives. Positives win. This 4 is our remainder. I'm just going to put R for remainder. This is our quotient. Here is our divisor. And so this function that we started with can be rewritten as quotient 2 plus remainder, which is 4. I wrote it 2. 4 over divisor. And the divisor is x minus 3. And now this form looks just like we had yesterday. The only difference is, was the 2 in front or was the 2 at the end? Yesterday it was at the end. So however you want to write that, all right, I don't care. But this is how I'm going to go with it today. Same thing. So we did long division to simplify the form into what we did yesterday, which is kind of cool. So now vertical asymptote, horizontal asymptote. Did this just blow your mind, Anthony?
No.
Oh, darn. I thought you had like one of those really awful moments. No. That had nothing to do with math, did it?
Oh, no, it did.
Oh, it did? Oh.
Just how much? It's a lot.
Oh, you mean we're not done yet?
Yeah, the fact that we're not done.
Well, that's why you only have 6 problems on your worksheet. So. All right. What is the vertical asymptote? X equals 3. Very good. What is the horizontal asymptote? Y equals 2. Very good. Let me go ahead and make a little sketch. You should know today that some of the remainders are going to get really large, like 10, 12. And so it might make your ordered pairs be off the page. That's okay. Plot them, graph them. So here we go to the x-axis where x is 3 and we draw our vertical asymptote. We go to the y-axis at 2 and draw our horizontal asymptote. And then I need some ordered pairs. You can use a calculator or your brain. I'm going to use my brain. Our vertical asymptote is at 3. What are some good values for x? 2 and 4 are great choices. 2 and 4 are fantastic choices. So I'm going to go ahead and plug the 2 into my little function here. So I'm plugging the 2 in place of the x. 2 minus 3 is -1. 4 over -1, -4. So this is 2 minus 4, which is -2. So that's my ordered pair that I am going to plot. 2 for the x, -2 for the y. And again, I'm just going to make a nice little L shape. When I plug in the 4, place of the x, 2 plus 4 divided by 4 minus 3. 4 minus 3 is 1. 4 divided by 1 is 4. 2 plus 4 gives me 6. So I have the ordered pair 4, 6. 1, 2, 3, 4, 5, 6. 4, 6 is right here. And again, I just need that sort of L shape in those border walls. Let's just be clear, I'm for open borders. But okay. I don't mean to turn math political or anything. But okay. All right, questions on this one?
Yeah.
All right, one more. Y equals -3x plus 2 over x plus 1. Is this simplified or not simplified? Not simplified. And because it is not simplified, since we have that x on top, not simplified. Not simplified, we're going to do some long division. X plus 1 into -3x plus 2. I hope you're getting your notes copied down over there. A lot of chatter. What are we dividing first? -3x by x. Yeah, the leading terms. What is -3x divided by x? -3. All right. Then we're going to multiply. -3 times x is -3x. -3 times 1, -3. Then we're going to subtract everything. -3x minus a -3x. Minus a negative becomes positive. So -3x and positive 3x is 0. 2 minus a -3 becomes what? Positive 3. So 2 plus 3 gives us 5. This is our remainder. What is negative 3 called? Quotient. What is x plus 1 called? The divisor. And so we can rewrite this as quotient plus remainder over divisor. So here is our simplified form. And now we can write what's our vertical asymptote and horizontal asymptote. Go ahead and do that. What's our vertical asymptote? X equals negative 1. And what's our horizontal asymptote? Y equals negative 3. So as a reminder, vertical asymptote should always say x equals, and that always comes from this thing in the denominator, where we are just simply solving for x. And when you solve for x, there it is. That's the equation, x equals negative 1. That's the equation of our asymptotes. That always comes from the denominator. All right, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, graphing my asymptotes. I'm going to go to negative 1 on the x-axis and draw a vertical line. Going to go to negative 3 on the y-axis and draw in my vertical line. And make a little XY chart. What are some good values for x? 0 and negative 2. Yeah, negative 2 and 0. Great choices here. To the left of negative 1 and to the right of negative 1. And now I'm going to take my x value and plug it in for x. Negative 3 plus 5 over negative 2 plus 1. Taking my negative 2 and plopping it right in for x. Negative 2 plus 1. I have to do that first, is negative 1. What's 5 divided by negative 1? Negative 5, that's right. And negative 3 and a negative 5 is going to give me negative 8. So sometimes we are going to get some larger numbers here. That's okay. I'm just going to pretend they're there and graph it as if they were there. So negative 2, negative 3, 4, 5, 6, 7, negative 8. Negative 2, negative 8. And I'm going to make my little L shape. That just goes right along my little fence there. Going to plug in the 0. Negative 3 plus 5 over 0 plus 1. 0 plus 1 is 1. 5 divided by 1 is 5. So negative 3 plus 5 is just 2. 0, 2. 0, 2 is right here. And again, I'm just going to go right along my fence lines to make my hyperbolas. All right, ladies and gentlemen, do you have questions for me? Alrighty. I'll pass out your worksheet for you.